Okay, so we want to graph this rational function, and I'm going to bring up those steps that were in our notes. We did something similar for our polynomial functions earlier in 4.2. Okay, so we'll kind of reference this throughout. The first thing we want to do is think about the domain, and really that first and that second option go hand in hand, right? Finding those vertical asymptotes means that we're finding the places where our function is not defined or things that are not in the domain. So to do that, we set that denominator equal to 0, and we get x is -2. So this represents a vertical asymptote. So that part's actually already done, but it ties into that domain question. So if you remember, one idea is to kind of graph this out on a number line. And so we're looking at -2, right? And we are actually going to shade in everything else, okay? So your domain here, I guess I did those two out of order, but your domain is -infinity to -2 union -2 to infinity. And the reason why we do the domain so early is it's actually really helpful for us because it gives you a set of points that you're allowed to use, that you're allowed to plug into your function. Pretty much everything but -2, we're good to use, okay? Now we want to look at any horizontal or oblique asymptotes. And to do that, if you remember, swap colors here, if you remember, we're looking at our leading term in the numerator and in the denominator. So remember, we start by looking at horizontal asymptotes. If I just look at those leading terms, we've got x over x, and these are the same degree, right? So according to our tests, or if you'd like, this is that second case 2, but according to our tests, because the degrees are the same, we look at the coefficients, and there's not one formally written in there, but it's going to be 1, right? So we look at the coefficients, and we say that our horizontal asymptote is at y is equal to 1 over 1, or maybe better yet, y is equal to 2. You know what actually might be really helpful is if we start to sketch this out so we kind of have an idea. Remember that there's only horizontal or oblique, so in this case there's no oblique. We're done with horizontal. So let's actually graph this. Take this out. Okay, so we've got some axes here. Again, you always label, you always put arrows on all of your axes. And so far, the information that we've got is we know we have a vertical asymptote at x is equal to -2. If I break this out again, let's label. So this would be -1, -2, and I'll keep the color the same just so we can track it. But here at -2, okay, so we've got that, and this one does get arrows on it. It's different from just breaking up it's different from just breaking up the set of all real numbers, right? This axis for test points. This vertical asymptote is maybe not kind of an official part of the graph, but its job is still to give us some idea of how the graph looks. So it is there, and it does have arrows with a line. The other thing we'll sketch in here is our horizontal asymptote, and that's up here at y is equal to 1. Again, dashed lines, they're not like formally part of our graph, but it does give us a way of understanding. So, okay. And also, again, horizontal asymptote. And again, you should label just enough so that's clear, right? I may not need all of these individual numbers marked, but enough so it's easy to read your graph, okay? So we've gone through the first couple steps up here. The next thing we want to do is find the zeros of the numerator, and I can label, this was step 1 and 2. This was step 3. Now if we move to step 4, we're looking for, it says zeros of the numerator. So to do this, you actually set the numerator equal to 0. Well, for us, that's x minus 3 is equal to 0, which translates to x is equal to 3. And what this is the zero, or kind of the root of it, also known as the x-intercept. So we can actually graph over here at x is equal to 3, and you can treat this like an ordered pair. X is equal to 3, y was equal to 0, right? That's what we set it equal to. So we can mark 1, 2, 3, and there's a point right here. And that means our graph is going to cross through that point. Right? The other thing it recommends that we find is a y-intercept. Well, that's kind of a reverse process. So we would say, so to find that y-intercept, we're going to take x plus 3 over x minus 2, and we're going to set it equal to 0. Well, we're going to find f of 0. Well, for us, that's 0 minus 3 over 0 plus 2, which is negative 3/2, or negative 1 1/2 if you'd like. So that's on the y-axis. And again, if you were thinking of that as an ordered pair, it would be 0, negative 3/2. So that would be down here. So this would be maybe like negative 1, negative 1, negative 2, which would put it right about there. That's actually pretty useful because it gives us a good idea of what this bottom portion is going to look like. I'll do it with a highlighter real fast, but I'll draw it in officially. But it might look something like this as we kind of move forward. So it gives us a good idea without doing any extra work yet. So we found the zeros of the numerator. We found the y-intercept. There was one. And then the idea for 6 and for 7 is really just, is there anything else that we can think of? Are there any other values or any other points that we can maybe plug in where we're not certain of what the graph looks like? So as I mentioned before, I think it's pretty reasonable to say we have this curve over here. I can maybe make this side a little more curved, like that. But we have this nice curve over here. But what does the graph look like on this side? We have actually no idea. Does it sit up here? Is it down here somewhere? Again, we just don't know. The best way to figure that out is to just plot a couple of points. So this is to the left of negative 2. It's to the left of this point right here. So let's plot some points to the left. Let's plot some of those points. Let's just pick, again, there's not really anything particularly special. It'd be kind of like an XY table, or an XF of X table. So if we pick values to the left, maybe like negative 3, f of negative 3 would be negative 3 minus 3 over negative 3 plus 2. That would be negative 6 over negative 1, which is 6, right? That's actually pretty useful information because that means over here, if we go to graph, at negative 3, 1, 2, 3, 4, 5, maybe 6 is right about there. My spacing might be a tiny bit off. But we might have a point right about here. Well, that's a pretty good indication that this is above this line. Now, one thing we actually hadn't done is we hadn't checked, do we cross this horizontal asymptote? And now might be a really good time for that. I'll put, does f of x cross y is equal to 1? Now, most of the time, no, but horizontal and obliques, they potentially could, and we always want to check. So I take my function, x minus 3 over x plus 2, actually set it equal to this one. So I'm going to multiply that up and over. I'll have x minus 3 is equal to 1 times x plus 2, which is x minus 3 is x plus 2, right? If we subtract x's, those cancel and we're left with negative 3 is equal to 2. Well, that's false, right? Which means no, it does not cross. So we're definitely going to stay above this axis or horizontal asymptote, or below this horizontal asymptote, it won't cross through. And like I said, it's not super common, but so just finding this one point up here is actually a really good indicator that we're going to be somewhere up here as far as a curve goes. Now, One more point might be helpful. Can we plug in one more? Let's try negative 4. Negative 4. So let's plug that in. So negative 4, f of negative 4 is negative 4 minus 3 over negative 4 plus 2. That's negative 7 over negative 2. Or if it helps, that goes in 3 times. That's 3 and 1/2. So negative 4 is here. This is 1, 2. There's 3. And that would be maybe that halfway mark. So we would have a point right about here. And again, that might be a pretty good indication. I would argue that's fair enough to know we have this curve going on. If you're uncertain, do a few more points, right? Plug in negative 5 or negative 10 just to see what happens. And I have a lot of different colors going on here. Let me actually graph that last line in orange so that it matches. So I would say your graph looks something like that. Okay, so this actually ends up being in that same family as 1 over x, that baseball graph, something like this, but maybe a little more clearly defined because we walked through the whole thing. Okay, we have a few more like this, so you'll get lots of practice. I'll see you in just a bit.